Hey guys, hope you all are doing well. If you have been using Linux for a while, I can guarantee that you have heard about the statement everything in Linux is a file. Now, what do we mean by that is Linux represents everything as files or either a process, right? If anything in Linux is not a file, it must be a process. There cannot be a third option. So, what do we further mean by that is, let's say there are these hardware, right? There are several hardwares in a system, in a machine. All of these hardware are represented as files as well. There can be other things. For example, network sockets. These sockets will be represented as files as well. There can be pipes. There will be files as well, right? So that's how it works. What do I mean by that exactly? For example, there's a directory. You can make this argument that hey, there are directories. How can you say these are files? So yes, these are files as well, because they actually are files with some metadata in it that says okay, these are all the children that I contain, all the files that I have, right, and all the even child directories that it has, right? So it is again just a file with some metadata. Now, what is the benefit of doing so? Representing everything as file in the ecosystem. So the benefit here over is, for example, there is a process that wants to read data or write data to any hardware, right? Now, it, as we are representing everything as files, the process will not care which hardware is it. It will be like, okay, I'll just make read and write system calls. I'll let the kernel handle everything for me. It will not care where the data is coming from and where the data is going, because for process can think everything as a file. So for example, it might be, let's say there is a program that is recording voice from your microphone and storing it onto your disk. So it will not care like where the data is coming from. It will like, I am reading from a file, copying it and saving it to another file. Whereas in reality, the data is coming from a microphone and it is being saved on a hard drive. These are two different, altogether different hardware. But still, a process doesn't care, because in that context, everything is a file. For process, everything is a file. Now, are there any physical representation of these hardware kind of files in Linux? Yes, there is. If you go to /dev directory, so basically this will contain a single file for a device, for a hardware, right? And even these TTYs, these are terminals. So even these terminals are represented as devices, right? Now you can explore this directory more. There must be some devices missing over here, and I'm using WSL right now and not on a native Linux machine. So you can try it on some VM or something, and you can spot the files over here. Now, who creates these files, and what are the benefits of creating this file, right? So what happens right now, let's say when you plug in a device, your kernel will know what to do with that particular device. And how does it know? There is something that is called device drivers that are already being written with the kernel. So it is like when you plug in, so that code provides the intelligence to kernel to like what to do with a particular device, right? For example, you plugged in a microphone. How does kernel know what to do with it? So there is a device driver that will take care of that, right? Now, as soon as you plug in any device onto your machine, kernel will load that particular device driver module, and then that device driver module actually generates a message, and that message goes to something called as udev manager, right? So what does this udev manager or daemon do right now is it will get that signal, interpret it. It has some comprehensive configurations written already, so that it will know what to do with each signal. So and as soon as it got is so as soon as it gets the signal, it will do certain steps. It will make a file that is there in the dev directory. It will link the device and the device driver in that file, so that your kernel will know what to do when a write or read is coming for that particular file. This is what actually this very good answer from Stack Overflow explains as well, right? So when there is a when UDEV gets a message, it will actually create a node with specifying the device driver number and the some version as well, right? So that's how the whole flow is when you plug a new device onto your machine. And the devices that are not being plugged in like real time after system is up, all of these are created while you are either during the boot process or when you are actually installing the distro. So this is how it works. There's some another things as well, like there are two types of file. There's a special character file and there is a block device file. What is the difference between these two? Special character files are, think of them as a devices where you will write character by character. For example, a network socket. For example, another a microphone, right? All of these you can write byte by byte, single byte data, or character by character, and that will be fine as well. There are some devices where you cannot write character by character, you will write block by block, and these are block devices. For example, your hard drive, right? In that case, you actually need to cache the data first until it is the size of a significant block. Then you will flush that data, that block, onto your main device. So this is how these two types of files are different. They differ slightly, but end of the day, pretty much it is the same thing. They are representing a hardware onto, like, in that dev directory. If you do a ls minus l over here, not here, in the dev directory, so you can see this, there is a C here, right? So what do I mean by that is, this file is actually a character special file and not a block special file. So this is pretty much it about the video, guys. If you like the video, drop a like, subscribe to the channel, and I'll see you in the next one. Thank you so much. Bye bye.